This video provides a little quick review on problems where there's an object moving up an incline. So let's say we have a car traveling up a road, and the angle the road makes with horizontal is theta. And the first thing we might be asked to do is draw the forces acting on this object, this car. Well, we know that there's going to be weight pulling down. We know that there's a normal reaction force pushing up perpendicular to the surface of the ramp. If the car is moving up, then there must be some thrust, some driving force provided by the engine. Thrust is what I'm calling it here. And that's an IB term that's accepted. And then if it's a car, cars are real-world objects. This is a road, which is a real-world object. They didn't say it was frictionless, so you assume that there's friction. Friction. It's good to write out the full word. So here it's good to write normal reaction. This, you write weight. I'm just being lazy because that's what teachers do. No, just kidding. Okay, so the next thing you might be asked to do is to find something with these forces. And usually that will require breaking the weight into the x and y components. Wx, Wy. And we all remember from last year that this angle is the same as this angle. Those are both theta. So that's a theta. The components always make the legs of the right triangle. So here's one leg, here's the other leg. They are at a right angle to each other. Weight, therefore, is the hypotenuse, right? Don't get confused and try to make this. Don't try to make a right angle between weight and the x component. Components are the ones that make the right angle, not the hypotenuse, not the weight. So Wy, in this case, it's a leg of the triangle, and it's the adjacent leg to this angle. So it equals cosine, it's the adjacent, so it equals W cosine theta. The x leg is opposite. Here's the x leg. We could bring it down, and it would form this right triangle, and in which case it would be opposite theta. So that's then going to be W sine theta. There's no acceleration in the tilted y direction because the object isn't moving off of the ramp. It's not sinking into the ramp. So there's no acceleration in this direction, which means there's no net force in the tilted y direction. Therefore, the magnitude of the normal force equals the magnitude of Wy. So the normal reaction is simply W cosine theta. And these are positive values. All of my forces, I'm just letting all of them be positive, and then I'll subtract values as needed. If the problem were to also tell us that the object, this car, is moving in a constant velocity, right, with a constant velocity up the ramp, constant velocity means there's no acceleration up the ramp, which would mean that the forces, the net force up the ramp, or the net force in the tilted x direction, would thus also be 0. If that's true, then the thrust would equal friction plus Wx. Right? This would also be true if the object was moving at a constant velocity up the ramp. So only when we have constant velocity does this last equation apply, this one. And again, I'm just going to plug in a positive value for thrust, and I'm going to plug in positive values for friction and Wx. If you want to plug in negative values for friction and Wx, if that's what you want to do because they are pointing down the ramp, then just put in negative thrust equals the sum of these two, because the signs must work out however you choose to do it. But I want to just plug in positive values, and then I use my drawing to indicate direction. So I'm not going to put negatives in for direction. Now this is a good picture to memorize, but always remember, if asked to just draw the forces, we only have 4: weight, thrust, the normal reaction, and friction. And we might not even have friction, because the problem could say that we are moving up a frictionless ramp. But once it comes time to solve, to do some work, we will probably need wx and wy. That's okay. You draw them somewhere else, right? Find a good place to draw those and remember these equations. And that will help you solve problems of this nature.